Hello and welcome to Electrofi channel. In this video we are going to introduce three-phase induction machines and explain about physics behind them. Here you can see our DIY induction motor on the left side, and on the other side there is an industrial one. To understand how the induction or asynchronous machine works, we need to know some basics that will be discussed. First of all, we are dealing with a current loop. The clockwise current which goes through the loop causes the magnetic field inward the coil that is shown in the green color. The counterclockwise current which goes through the loop causes the magnetic field outward the coil that is shown in green color. And it's very obvious that if we don't have any current, we will not have any field. Another basic is Faraday's law. According to Faraday's law of induction, if the magnetic field flux changes by the time in a loop, it induces EMF voltage which causes the current in a closed loop of wire. The current makes a magnetic field which opposes with the source. According to the Lorentz Force law, if current goes through a wire and we have magnetic field as well, force is applied to the wire which its direction can be figured with the right hand rule. Like other machines, induction machines consist of two general parts, stator and rotor. First we are going to talk about stator. There are three coils in the stator that is connected to the three-phase voltage which produces magnetic field which induce a voltage in the rotor due to the Faraday's law. Each pair of coils have a 120-degree mechanical angle difference as shown in the picture. In these pictures, every phase is indicated with different color. On the left side, we have a schematic of a stator, and on the right side, we have our handmade three-phase induction motor. These coils with 120 degrees phase difference electrically and also mechanically will make a rotating magnetic field. In this picture, three-phase voltage is shown by the time. As I said before, sum of the three-coil magnetic field is a rotational field. It has fixed peak magnitude that has frequency of power system 50 or 60 Hz. In these circles shown above, you can see the rotational magnetic field as a black arrow in different times. Now let's get deeper. Here the blue coil has its maximum voltage value, but the green and red coil have a smaller negative of their maximum voltage value. Magnetic field of every phase is shown in different color. Finally, the vector sum of these vectors, which is our rotating field, locates on the 6 o'clock. Here, the red coil has its maximum voltage value, but the green and blue coil have a smaller negative of their maximum voltage value. The vector sum of these vectors, which is our rotating field, locates on the 4 o'clock. And here the green coil has its maximum voltage value, but the red and blue coil have a smaller negative of their maximum voltage value. The vector sum of these vectors, which is our rotating field, locates on the 2 o'clock. This animation gives you a better understanding of the rotational field. Now, let's get into rotor. Rotor is the moving part of this machine. But how its rotation is possible? The rotational field induces voltage in the rotor. The voltage causes current in the closed loop, and due to the Lorentz force, the rotor rotates. In other words, in the rotor, a rotational field is produced which interacts with the stator rotational field. There are two types of rotors for the three-phase induction machine as shown in these figures: squirrel cage and phase wound. Squirrel cage has several metal bars that are parallel and shorted. Current will go through these bars. Phase wound rotor has three-phase coils that are connected to slip rings with star connection. loads can be added to these coils via slip rings to have better motor starting. Now let's experiment. Here we have 3-phase windings in color of red, green and yellow. And we are using a soda can as rotor, which here acts like a squirrel cage. Here we have another simple model of asynchronous or induction motor. As you can see, there are 3 windings for 3-phase voltage, and they are located 2 by 2 with the angle of 120 degrees. Here we are using a simple can as a rotor. Now let's test these rotors. They more look like a squirrel cage, but with another stator. Here you'll see the rotor rotating. Extra point. If you change connection of 2-phase, the rotating direction will be changed. Let's see. For induction machines, there is something that is called slip. Slip is defined as shown. Ns is the speed of stator rotating field and Nr is the mechanical speed of rotor. If slip or S is lower than 0, then machine works in generator mode. If S is equal to 0, then no voltage is induced in rotor, because in this case the speed of rotor and rotating field of stator are equal. So based on Faraday's law of induction, no voltage should be induced in the rotor. If S is between 0 and 1, then machine works in motor mode. If S is greater than 1, then machine works in braking mode. Now about applications. 3-phase induction machines are mostly used as motor. 3-phase induction motors are widely used in industry, like in lifts, cranes, large industrial fans, and electrical cars, and etc. Thank you for watching and hope you enjoyed this video and learned good things.